Hi guys and gals, Mr. Sawa here. Wanted to review some circuit calculations with you. So if you will open up the activity, you may have already attempted these, but wanted to double check with you to make sure we're all on the same page. This is activity 1.2.4, circuit calculations. Number one's a bit confusing. These are three separate sub-problems within number one, and you're going to be using Ohm's law. If you'll remember, Ohm's law is V over I times R. Okay. On these, the key is to pay attention to units. So as we look at this first one, they're asking us to find current in amps, which is I. They're giving us a resistance of 470 ohms and a voltage of 3.5 volts. So we set up the equation for solving for I. You simply put your thumb over I, and you'll see that I equals V over R. Okay, our V is 3.5 volts and our R 470 ohms. As you put that into your calculator, 3.5 divided by 470, you get a very, very small number, 0.007446, so on and so forth, amps. So there's two ways you can write that answer. If you wanted to put it in amps, you could say 0.0074 amps. Or if you wanted to write that in a number that's a little more manageable, you could use milliamps. So multiply that number by 1,000, and that would be 7.4 milliamps. Either answer would be correct on a quiz, as long as you use the appropriate notation. However, when you're doing your calculations, you'll need to keep it in the amp unit. The calculations are set up for amps, not milliamps. Going on to number two, part B of number one. If you'll notice under current this time, they're giving us the current, but we have this little symbol, okay, and that is standing for microamps, okay, and if you forget your scientific notation, micro is 10 to the negative 6th. Sorry, my screen went all haywire there. But microamps is 10 to the negative 6th power. So really that number, you have to move the decimal point 6 places. So it will be the equivalent of saying 0.0000155, a very small number, but typically most currents are small. So as I plug that into the calculations, because we are solving for resistance, right, I'll say resistance equals V divided by I. I will say our voltage, which is 3.5 volts, divided by 0.0000155, and our resistance, then as you put that into your calculator, is 225,806 ohms. You could put that in kilo ohms if you wanted a number that was more manageable. That would be 22.6 kilo ohms. I want you to go on and try number 1C. Try the third problem on your own. Give that a shot now that we've went through those first two. Let me know if you have any questions. As you move forward to number two then, a couple things to keep in mind. On the two different circuits here in number two, they're simply asking you to find the resistance total. They're not asking you to use Kirchhoff's law. That'll come later. Just simply remember resistance total in a series circuit is all the resistors added up. So if that's R1, R2, R3, then we would find the resistance by adding R1 plus R2 plus R3. Give that one a try. Then here you'll see they have a parallel circuit. Same thing, resistor 1, resistor 2, resistor 3. The only difference now, the equation for total resistance in a parallel circuit is that monstrosity headache of an equation. The inverse of resistor 1 plus the inverse of resistor 2 plus the inverse of resistor 3, and then 1 over all of that mess. When you're putting it into your calculator, I suggest putting the denominator in first, finding that answer, and then simply doing a 1 divided by that answer to get your total value. So give those two a try, get them corrected if you've not done them correctly. As you scroll down to number 3, now you're going to do the full meal deal. They're giving you a series circuit with many values. You need to find all the missing items that they're asking for right here in the problem, and then use Kirchhoff's law to verify. I'll give you a hint. Kirchhoff's law on a series circuit says that the total voltage should be equal to the sum of all the voltage drops across the resistors. Okay, so that's your hint for number 3. And then for number 4, it's a parallel circuit. Again, solve for all the unknown values. Kirchhoff's law for a parallel circuit deals with the current, and it tells you that the current total is equal to the current at 1 plus the current at 2 plus the current at 3. Okay, so these should give you little tidbits of information. I'm okay with you working in small groups to kind of drudge through this and discover on your own, learn, and hit me up with any questions if you may have any. Good luck.